So Unit 3 is all about factoring. And the reason I like to do factoring before getting into quadratics is I want to have the mechanics and the tools before we get into actually looking at graphs and manipulating things on the graphs. So the first thing we want to do is we want to expand. That's the opposite as factoring. And so the way we expand something that is a binomial times a binomial, two terms times two terms, is we do FOIL, first, outside, inside, last. So what we do is we take the x and we multiply it by 2x, and that gives us 2x squared. That's the first two terms. And then what we do is after we get the 2x squared, we go to the next, the outside terms. It's x times negative 7, and that gives us minus 7x. And then we go the inside, that's 5 times 2x, which gives us 10x. And then the last, 5 times negative 7, which gives us negative 35. Now, the middle two terms are like terms. The minus 7x and the positive 10x can be combined, so we get 2x squared plus 3x minus 35. Now, I want to show you that FOIL isn't the only way to do this. The whole idea is that we're multiplying every term in the first set of brackets by every term in the second set of brackets. So one way to do that is I could take the x in the first set of brackets and multiply it by the 2x minus 7. And I could take the 5 in the first set of brackets and also multiply it by the second brackets, 2x minus 7. Now we're going to use the distributive property to multiply x times 2x and x times negative 7. That gives us 2x squared minus 7x. And then the distributive property again, 5 times 2x gives us 10x, and 5 times negative 7 gives me negative 35. Again, collecting the like terms in the middle, we get 2x squared plus 3x minus 35, the same answer that we got on the left. So whether you use FOIL or you just go ahead and multiply every term in the first set of brackets by every term in the second set of brackets, you get the same result. Now what we have there is the expanded form. And so the factored form is what we started with. And so we can go back and forth between those two forms. We've just expanded it this time, but normally what we want to do is we want to factor it because it allows us to be able to graph quadratics in the next unit. So let's go ahead and look at factoring. So the first factoring question says this. It's 2a, and it says 4x squared y cubed minus 16x cubed y squared minus 24y. And so we always want to start by common factoring if possible. So here the only thing that's common as far as the number that's a common multiple is there's a 4. The x's, there's no x in the last term, and the y, there's only one y in the last term. So that's why we can only common factor a 4 and a y. So then we divide every term by 4y, and we're left with x squared minus 4x cubed y minus 6. And now that is unfactorable, and so we've gone as far as we can go, and technically we factored it, but we can't go any further than that. So now to the second situation. The second situation is one that what we did previously up above, we would have just expanded it out. But we don't want to expand here. We want to actually factor it. We want to go the opposite direction. So to go the opposite direction, rather than going 2x times x and 2x times minus 7, we want to think, what would it do if I went back a step in the expansion? Well, that would be the 2x plus 3, and then you have that x minus 7 that's a common factor to both 2x and to 3, and so you write it out like so. So there you go. That's the second example. Now to the third example. 2x squared plus 10x plus 8. Now we see the 2, and initially that seems to be making things more difficult, but we can common factor first. We always want to do that first. So that gives me x squared plus 5x plus 4. And now it's a simple trinomial. I need to find two numbers that add to the middle term, 5, and multiply to the last term, which is 4. And so those two numbers are 1 and 4. And the nice thing about a simple trinomial where we have a 1 in front of the x squared term is that we can just go ahead and write the final answer out. We don't need to do any decomposition or anything because that is the answer. It always will be. So we still have that factor of 2 up front, but we have x plus 1 times x plus 4. And you can expand that back out to check to see if you got it right. D now is one where we can't common factor out that 3. So what we have to do is we have to find two numbers here that add to the middle term, minus 10. And in this case, because the 1 is not in front of the x squared, we need to go 3 times negative 8. We need to multiply the a times the c terms together. So we want to find factors of negative 24. And so 1 and 24, but we look at it because it has to add to a negative, we want the bigger term to be negative. And that doesn't work, but the 2 and negative 12 does. So 3x squared plus 2x minus 12x minus 8. Here's where I have to use factor by decomposition. So we're going to take the first two terms and common factor out of those. So an x out of both of those gives me x times 3x plus 2. And now I want to take a negative 4 out of the next two terms, and that's also going to give me a 3x plus 2. The key there is if those are not the same, you haven't taken out the right value or haven't factored things properly. They have to be the same, and the signs also has to be the same. So just like we did in B now, we're going to take that last step. We have that x minus 4, and the common factor is 3x plus 2. So that's our final answer as shown. And just note that negative had to be factored out in order to get it to work out with the right signs, as I mentioned. All right, let's look at the next example now. 16x squared minus 121y squared. This is a difference of squares. The idea here is that we have two squares and there's a difference between them, the minus between them. Basically, anytime you see two terms, it's probably going to be a difference of squares. It might not be, but it usually will be. So the idea here is if we take the square of the whole first term, we get 4x, and that's 4x all squared, because the 4 squared would give us back the 16. And then we have 11 squared would give us back the 121. So it's maybe easier to see there. So now we take the 4x and the 11y, we write it out as adding them together and subtracting them from one another. And so the general form of this, just if you're not quite following with this, is that if we have an a squared minus b squared, it's equal to a plus b times a minus b. And so in this case, the a was 4x, the b was 11y, so we wrote 4x plus 11y and 4x minus 11y. So on the right, we have a situation that is a perfect square. Now, we might not see that initially, but what we're looking at is the first and last terms. So we can see the first term, we can take the square root of that, and the last term, we can take the square root of that. If we take the square root of the first term, it's 3x. If we take the square root of the last term, it's 2y. And so then we look at the middle term. We say, is the middle term twice 3x times the 2y? And if it is, which it is in fact here, 2 times 3 times 2 gives me 12, and x times y gives me xy, then it is a perfect square. And so what we're going to do here is we're going to write it as 3x, and then plus or minus 2y. Well, it's a minus if the minus is in front of the second term. And then we write that all squared. So the general form in this situation, if we wanted to see that play out here, would be something that is in the case of a squared minus 2ab plus b squared is equal to a minus b all squared. Remember, the sign of the second term is the sign that's going to be between the a and b. So if I have a plus 2ab plus b squared, then that's going to be a plus b all squared. And so those are your two forms that you're going to have for a perfect square. So we've got tricky trinomials, we've got simple trinomials, we've got common factoring, differences of squares, and now perfect squares as well. So let's see what we would do if we were asked to solve the following quadratic equation. We have x minus 10 times 2x plus 3 equals 54. To solve, we need to have it equal to 0. And so in order for us to get this equal to 0, we actually have to expand this out and get everything on the left side of the equation. So we want to subtract 54 from both sides of the equation. So what's going to happen here is I'm going to go ahead and I'm going to use my FOIL again. You can expand that however you want, but the whole idea is that every term on the left has to be multiplied by every term in the other set of brackets. And so we get x times 2x gives me 2x squared, x times 3 gives me 3x, negative 10 times 2x is minus 20x, and negative 10 times 3 is negative 30. So there we have equaling 54. Now to get that 54 to the other side, we're going to subtract 54 from both sides. Whatever you do to one side, you have to do the other. And we're also going to combine those like terms on the left. So we get 2x squared minus 17x minus 84 equals 0. So now it's in a form where we can solve it because it's equal to 0. But now we have to actually go ahead and factor again. Now we can't common factor here because we can't take a 2 out of 17. So we're looking for two terms that adds to the middle term of negative 17, multiplies to 2 times negative 84, which is negative 168. This is going to take a little bit of work. I'm going to do it pretty quickly on the screen, but in reality, it's something that takes a little bit more time as you actually do it. So first thing we're going to do is we're going to look for factors of 168. 1 and negative 168 is nowhere near negative 17. We're just going to keep working through the factors that we can find, doing this on our calculator, dividing by 2, dividing by 3, dividing by 4, etc., and then adding those two factors together. And you can see here that we're getting closer to negative 17, but we're not there yet. 4 and negative 42 gives me negative 38. When we get to 6, 5 is not possible. We get to 6, 6 and negative 28 gives me negative 22. We're very close now. And then 7 and negative 24 gives me negative 17. Awesome. So that means that negative 17x is going to be decomposed into 7x and negative 24x. So you can see that I'm breaking that down into those two terms there. So just as shown, and that's the same thing as the line above it. So now what I want to do is factor by decomposition. So I'm going to take the first two terms and x out of those two terms. And now what I want to do is I want to be left with an 2x plus 7 in the brackets in the second case. So I'm going to take out a negative 12 to get that 2x plus 7. And 84 divided by negative 84 divided by negative 12 is in fact positive 7. So that's going to be equal to 0. And so now just the last step, we go x minus 12 times 2x plus 7. I said that's the last step, but that's the last step in factoring. That's not the last step in this question. It's asking us to solve it. So what we actually have to do is we have to go x minus 12 is equal to 0, or the 2x plus 7 is equal to 0. So we add 12 to both sides here. We get x equals 12. On the right side, we have to subtract 7 from both sides. We always do reverse order of operations, so we have to subtract or add before we multiply or divide. And then we divide by the 2, and negative 7 divided by 2 gives us x equals negative 7 over 2, or negative 3.5. So there you go. Those are your two solutions for solving that quadratic equation. So we've gone over a lot of different things, noticing that we had to expand it initially, then we had to factor it, and then we finally had to solve it. Comment below on which type of factoring you find the most challenging and why. See the video on the right for more on factoring. For a playlist of all the review videos of this course, click on the left. If this has been helpful, please like and subscribe. Thanks so much for watching.